In this video here, I'm just going to continue with our techniques for partial fraction decomposition. I'm just going to do a couple more examples here using the other parts of our table. So we're going to be looking at this example here specifically deals with irreducible quadratic factor. And then the last example will deal with maybe a repeated one or something like that. All right, so let's go ahead. Let's do this. So we want to integrate 2x minus 3 all over x to the third plus x dx. And let's just go ahead. Let's look at this. Remember, our degree of our numerator is definitely less than the degree of our denominator. So it's 1, which is less than 3. So we're definitely going to use partial fraction decomposition. And remember, we're going to look at that denominator, and we're going to try to factor it down as much as we can. So we end up with a denominator of x times the quantity x minus 1. Or I'm sorry, x times the quantity x squared plus 1. So now the question becomes, okay, well, how do we set this up? Okay? And remember, when you look at your chart, when you have an irreducible quadratic factor, what we're going to do is we're going to rewrite this as ax plus b over x squared plus 1. This is our irreducible quadratic factor. And then since we factored out the letter x, and that's linear, we're just going to make it c over x. Now, approach is still the same. I'm going to go ahead and set 2x minus 3 equal to, and then we're going to use the numerator, the quantity, ax plus b, and we're going to multiply by x because we know our denominator here is this x times the quantity x plus 1. Since we already have the x squared plus 1 right here, all we need to do is just multiply it by x. Next, we're going to take c and multiply it by the quantity x squared plus 1. We're going to do some basic algebra here. 2x minus 3 equals a times x squared plus b times x. Distribute the c as well. Cx squared plus c. Let's go ahead and let's group the ax squared plus the cx squared plus bx plus c. We're going to factor out the x squared from the first two terms right here. We'll factor out these factor out the x squared. I want this to look nicer. There we go. So we're going to have a plus c with the x squared factored out plus bx plus c. And I'm going to put those in parentheses as well, just because I know they're separate terms. And remember, on the left-hand side, you do not have an x squared term, so it's 0x squared plus 2x minus 3. And now we can go ahead and set up our matrix. So remember, this is going to be equation 1, equation 2, equation 3. And those equations are going to be a plus c equals 0. Let me give myself some space here. A plus c equals 0. And then b equals 2. And c equals negative 3. So if you really wanted to, I mean, we don't even have to do a matrix with this one. All right? I'm going to do it anyways just so you can see the technique again. But just judging by what we have over here on the right-hand side, we know b equals 2. We know c equals negative 3. Therefore, a plus negative 3 equals 0 means a is going to equal positive 3. So we already, I mean, this is a nice example where we could just clearly see what we have right off the start. And that's really awesome when that happens. But once again, I'm just going to show you how to do this on your calculator because I think it's really important that we see stuff like this. So we have a B, C, and then our output. So equation 1 is going to be 1, 0, 1, 0. Equation 2 is going to be 0, 1, 0, 2. And finally, equation 3 is going to be 0, 0, 1, negative 3. And let me go ahead and get my calculator out of here real fast. All right, so here we go. 1, 0. Okay, I just got to remember these, which is going to be kind of difficult here. You know what I'm going to do is I'm going to do this. You're going to let me maximize there. I think that'll work. There we go. That's not too bad. All right, so remember, we're going to go to the matrix. We're going to go to edit. In this situation here, we have a 3 by 4 still, so that's good. 1, 0, 1, 0. Row 2 is 0, 1, 0, 2. And finally, row 3 is 0, 0, 1, negative 3. All right, let's go to quit. And then we're going to go back to the matrix. Remember, scroll down underneath the math menu to RREF. We're going to select matrix A. And as you can see here, we have 3, 2, negative 3, which if you look on the right-hand side, A equals 3, check. B equals 2, check. C equals negative 3, check. So we are good there, which is awesome. I'm just going to go ahead and just copy and paste this into our notes. There we go. So here we could see, like I said, A equals 3, B equals 2, C equals negative 3, which means our integral now is going to look like this. The integral of 2x minus 3 over x to the third plus x dx is going to equal the integral of 3x plus 2 over x squared plus 1 minus 3 over x dx. So we can go ahead and easily integrate this. So let's go ahead and do that. Initially, and you're going to have to do a little bit of algebra here, all right? But you're going to get 3 times the integral of x over x squared plus 1 dx plus 2 times the integral of 1 over x squared plus 1 dx minus 3 times the integral of 1 over x dx. So all I did here is I took my numerator and I took this denominator and I separated them. So like right here is your 3x over x squared plus 1. Right here is your 2 over x squared plus 1. And I just moved each one of those coefficients out front. So like I said, it's just a little bit of algebra. It's nothing too crazy. Nothing you haven't seen before. And now going from left to right, when you integrate, you're going to get 3 over 2 times the natural log of x squared plus 1 plus 2. You're going to have to look this one up. This one I highly suggest you look up, okay? Because it ends up being the inverse tangent. And minus 3 ln of x plus c. All right. So let's see here with our last example, we're going to do basically the same thing. Nothing, like I said, nothing too crazy here. All right. But this one, it's going to have a repeated root. Okay. So let's go ahead and let's do this one. And this be like, I'll make this one a word problem for us. So let's find a volume 4 So, actually, yeah, you know what? I'm just going to write it out. You can write it along with me. Find the volume of the solid of revolution obtained by revolving the region enclosed by the graph of f of x equals x squared over x squared plus 1, or the quantity x squared plus 1 to the second power, and the x-axis over the interval from 0 to 1 about the y-axis. All right, so go ahead, pause the video if you need to, write this down, and I'm just going to move right into it. So the first thing we're going to do, let's go ahead and let's graph this into Desmos to see what this looks like, okay? All right, so let's see what we have. We have the ratio of x squared over the quantity x squared plus 1 raised to the second, and it's going to be in between 0 and 1. All right, so let's do x equals 0, x equals 1. All right, I'm going to make these the same color, and I'm going to use red for that, and let's go ahead and really zoom in on this. So let's go from x equals negative 0.5 to 2.5. That'll really zoom it in on the x. And then our y-axis, we're going to go from 0 to 1. All right, here we go. So this is really what we're looking at here. All right, can I make this look a little nicer? There we go. I kind of like that. So I'm going to copy and paste this into our notes just so we can have it for reference. Perfect. All right, I think that looks great. All right, so the area that we're concerned with, all right, is going to be right here. So this is the area, or the volume that we want. We're going to find the area of this, but then use that to find the volume. So I'm just going to shade this in a little bit. All right, beautiful. All right, so remember, the volume is given by 2 pi from 0 to 1 of, now remember, it's going to be the radius and its height. So this is going to be x multiplied by x squared over the quantity x squared plus 1 to the second dx. Because remember, we are going to be rotating this about the y-axis. So it's just going to be coming around like this. All right. So our representative slice is going to be right here. So it's just going to roll right around that y-axis right there. So now it's just a matter of simplifying a little bit. So let's go ahead. We have 2 pi. Actually, let me write volume, sorry. Volume equals 2 pi times the integral from 0 to 1 of x to the third over x to the second plus 1 all raised to the second power. And from here you can see that the degree of the numerator, which is a 3, is definitely going to be less than the degree of our denominator, which is a 4. All right? So we're going to go ahead and use partial fraction decomposition again, which is exactly what we want. But here we have a repeated irreducible quadratic factor. So this is a repeated irreducible quadratic factor. So when we go to set this up, like I said, we're going to have to use our other technique again. So x over 3 over x squared plus 1 quantity squared. And I'm going to go ahead and scroll up so I can get that, because I forget what that looks like right now. So here's all the work that we did. All right, let me erase some of this stuff here. It's not going to hurt us, but I definitely want this again, because I want us to see it. So I hope that copied and paste. Come all the way back down. In fact, I'm going to move this down here for now. And of course it didn't copy and paste. Why would it? Why would it work for me here? Let's try this one more time. Oh my gosh. You ever have one of those days where the technology just doesn't want to work with you? I'm having one of those days right now. So I want to copy. Here we go. Look at this. All right, now, please paste. Anyways, I'm just gonna give it to you because I'm not gonna mess with it. Like I said, it's just one of those days. I'll live and learn. Here we go. So looking at your chart, this is what you end up with: ax plus b over the first irreducible quadratic factor plus cx plus d over the irreducible quadratic factor raised to the second power. The thing to remember is anytime you have to repeat this, you're going to want to change those letters. So hypothetically speaking, if this was a 3 right here, then I would use x to the second plus 1. If you just go with the alphabet, A, B, C, D, E times x plus f. Like you would just keep going like that. Except this would not be a 2. It would be a 3. All right? So that's how this works. It's very straightforward. So let's go. Let's fix this. All right, there we go. And once again, it is nothing more than just algebra. So x to the third is going to equal the quantity ax plus b times, now you know your denominator has the quantity x squared plus 1 times the quantity x squared plus 1. You already have an x squared plus 1, so you just are going to multiply it by one of them. Now, the cx plus d over the quantity x squared plus 1 to the second power, you don't need anything there. So we're just going to leave it as cx plus d. Doing just a little bit of algebra, we're going to get ax to the third plus ax plus bx to the second plus b plus cx plus d. Let's go ahead and arrange these terms. We got ax to the third plus bx to the second plus ax plus cx plus b plus d. And finally, if I'm going to really be 100% honest with this, on the left-hand side, you get x to the third plus 0x squared plus 0x plus 0. There is a descending degree equals x to the third plus bx to the second plus a plus c x plus b plus d. And remember, these are going to be constants. So if I just write it like this, and the reason why I'm doing this here, all right, is there is a coefficient of a 1 out front of the x to the third, which if you kind of just look at this from left to right, you can already see that a is going to equal 1 because this term right here has to equal this term right here. All right? So we know a equals 1. We also know that this term right here, the x squared term, has to equal the x squared term over here. And since it's only the letter b, we automatically know b equals 0. So really what you're looking at are just these last two. So you can get through this without even setting up a matrix, just by taking your time and really understanding what's happening. So here, and I'm going to use a different highlighter. We'll use this color. We have the quantity a plus c has to equal 0, which means, and I'm going to write it on the right-hand side here, a plus c has to equal 0, but we already know what a is. A is 1, which means c has to equal -1. All right? And finally, b plus d, well, let me erase this real fast. Let me get out another highlighter. What color could I use? What's a nice one? How about this? How about that blue? That looks pretty. B plus D has to equal 0. So B plus D has to equal 0. But we already know B is 0. Therefore D is also 0 as well. So here's a great example where you didn't even have to use a calculator. Just understand how this relationship works. And it's really just, like I said, it goes back to algebra. Left side of the equation has to equal the right side of the equation. So our integral turns out to be, and I'm just gonna copy. Let's see if it'll work again. I don't know. We're gonna find out here in a second. Is this? Yeah, my key. I was making sure my keyboard was turned on. I was thinking maybe that wasn't working. And it just scrolls. Oh, it's copying all the way up there. Why is it doing that? Oh, I think I know why. Sorry, I am talking out loud right now, and I do not mean for that. Hey, look at that. Oh, I wish you could see my face right now. I'm so happy. So, just going in and substituting, a is 1, b is 0, c is -1, and d is 0. Which means I can really, really simplify this by saying the integral of x to the third over the quantity of x squared plus 1 to the second power dx is equal to the integral of x over x squared plus 1 minus x over the quantity x squared plus 1 to the second power dx. And don't forget, we have our limits of integration from 0 to 1. All right. Now, we need our 2 pi out front because we were finding a volume. And now we are good to go, I think. So going from left to right, you're going to get 2 pi times the quantity 1/2 times the ln of x to the second plus 1. This is going to be u substitution. Plus 1/2 times 1 over x squared plus 1. Once again, using u substitution. And all this is evaluated between 0 and 1. So when you substitute in your limits of integration, you simplify, you are just going to end up with pi times the ln of 2 minus pi over 2. And that's going to be our final answer, and it's going to be the end of this video. So I hope you found this informative. Remember, the chart really helps us out in terms of how to break down the partial fraction decomposition. And I will see you in the next one.